Hello everyone, welcome to All Chemistry. So as you have all voted to the coordination chemistry most, going for the coordination compound, and already the bifurcated syllabus according to the semester 2 for ISC and the reduced syllabus I have discussed, and I am going with the syllabus only. So we are going to discuss the coordination compound. Now coming to the coordination compound, this one is a very important chapter and there are many points. And if we go through the reduced syllabus, then what are the main points we have to study? The main points are: what is coordination compounds, means what will be the definition, then what is the difference of coordination compound with double salt, and how we can name the coordination compounds, means the IUPAC nomenclatures, and there we have the isomerism, the most interesting part. And then after that, few more things, few more points, we have small point. So without wasting any time, let's get started doing coordination compound. So coordination compound, by the name we can get it. In the coordination compound, first of all, the metal will be there and many other ligands will be there, and that metal and other ligands will be attached through coordination bonding only. So a metal and many ligands with the central atom can be metal or any atom, and that will be attached with the other ligand through coordination bonding only. Now, as you already know what is coordination bonding, we have three major type of bonding, that are ionic bonding, covalent bonding, and coordination bonding. So in ionic bonding, what is the main thing? The first ion will form, then they will attract each other through electrostatic force of attraction. Then covalent bonding means sharing of electron. Then in coordination bonding, donation of lone pair of electron from one donor atom to one acceptor atom. So this is the main thing of coordination bonding, and we express it through this arrow type thing. But in coordination compound, as all the bonds are coordination bonds, so we will not express through arrow, only by a bond. Then coordination compounds are the compounds in which central metal atom or ion is linked to a number of ion or neutral molecule, or both by coordinate bonding. Next, we will see few of the example of coordination bonding. If we go for nickel amino hexaamino compound, here 6 amine groups are attached with the central atom nickel through coordination bonding. So this one will be one of the example of coordination bonding or coordination compound. Next, a question will come. There are various type of compound where more than one metal, more than one anion, cation, ligands are attached, and there are many other type of salts also, like double salts, one of the example. So our next point will be, so our next point is the difference between coordination and double salt. The main and exact difference is in double salt there is ionic compounds, cation anions attached, and many ionic compound mixed together and gives the double salt. But in coordination compound, the salts are attached through coordination bonding, or the one compound only with coordination bonding. But in double salt, multiple salt of ionic compound. If we go for the difference, let's see what are the main points we can cover up. So coordination compound can be found in solid state as well as in solution form. And in solution form, they do not lose their identity in solution form. But in case of double salt, they when they will be soluble in solution, they will form ions and they will lose their identity in the solution form. If coordinate bonding is present in between central atom and ion, then also if ions are present in form of ligand, then other bonds are also possible in case of coordination bonding. So in case of coordination bonding, the central atom can be surrounded with ions as well as molecules. But in case of double salt, only ions exist. So these are the main difference in between coordination compound and double salt. This is also important to know. If we go for the few examples, for double salt we are having the salt K2SO4, Al2SO4 whole thrice along with 24 molecules of water. This one is a double salt named potash alum, whereas coordination compound I have given already one example. Here are the some important terms related to coordination chemistry which we need to discuss first. We can discuss the term in the form of some example first. Suppose we are having a coordination entity and coordination sphere. What is this? It constitutes a central metal atom or ion to a fixed number of oppositely charged. That means central metal atom which one we have, and the ions which it's attached with that central metal ion that are completely opposite in charge. And if we go for the coordination sphere, that coordination sphere will be the complex that we will express in third bracket. That one is the coordination sphere. This part is the coordination sphere. Now if we go for the charge of coordination sphere, the charge of coordination sphere can be neutral, it can be positive, it can be negative. For in this case, the coordination sphere having the charge 2 positive, that means this 2 positive charge is coming from metal nickel, because ammonia have no charge, that's why the positive charge is coming from nickel only. Now to neutralize the positive charge, we are having an outside sphere outside the third bracket. That one is suppose 2 chlorine atom we have taken, and each of the chlorine atom will give you one negative charge, that means total 2 negative charge, and that 2 negative charge will be neutralized by 2 positive of coordination sphere. Now which one is the coordination sphere? So this one under the third bracket will be the coordination sphere. And which one is the outer sphere? That one is the ionization sphere. So the outer sphere is the ionization sphere. Why so? Because the coordination sphere actually determines the spatial arrangement of that coordination compound. Whether the ionization sphere, if we ionize the sample, so it will ionize into nickel hexamino plus complex with Cl2Cl minus complex. So that 2 chlorine ion will go to the complex form. So this one is the ionization sphere, the outer part of the third bracket. Now the thing is, the coordination sphere can be of positive, it can be with negative, it can be with neutral. With the example we can explain this. Next, going for the another term, oxidation number of central metal. If we want to go for the oxidation number of central metals, so as we have nickel here, to find out the oxidation number, let's consider we don't know the oxidation number of nickel. We are having this compound only. Let us consider the oxidation number of nickel is X, and ammonia having no charge, that is 0. Along with chlorine with -1, that means chlorine having -2. Now the thing is to neutralize the thing, to neutralize -2 charge of chlorine, that coordination sphere should have a charge of +2. So X plus 0 into 6 equals to will be +2. So nickel having the oxidation number +2. So this one is the oxidation number of central metal ion. Next is the coordination polyhedron. Coordination polyhedron, actually the shape which is occupied by the ligand and the metal atom. If we go for the central metal atom nickel, around nickel 6 amino complexes, 6 amino ligands are there, 6 amine groups are there. They can be arranged in the form of octahedral. So actually in this coordination compound they have formed one octahedron. So coordination polyhedron is the shape of coordination compound of the spatial arrangement. Next, the ligands. What are the ligands? Ligands means the atom, the ion, or the molecules which are attached with the central metal atom, that are called the ligand. So we have got the term ligand. So here the ligands are amines. So here the ligands are ammonia, NH3 molecules. So the ligand here. So ligands are the atom or molecules or the ion attached with the central atom. Now what is which one is the central atom? So we can understand the central atom is nickel here. The atom which is surrounded by the ligand is the central atom. Now the question is coordination number. Coordination number means the number of ligand surrounding the central atom, or the number of ligand or molecule ions attached with the central atom is the coordination number. If we go for this coordination compound here, the number of the coordination number will be 6 because nickel is attached with 6 other amine group. Here the coordination number is 6. So these are the few important terms which are related to coordination chemistry. Now we will find out few of the example where we can find out the oxidation number, ligands and the ionization sphere, etc. Let's go for it. Okay, our example number 1. So here in example number 1, first of all we are having this one in the third bracket is the coordination sphere. So this one is the coordination sphere, and we are having chlorine outside of coordination sphere. Which one will be ionization sphere? Now, in ionization sphere, as chlorine is out from the third bracket, it will be the ionization sphere. The chlorine which will be inside the third bracket, that will not be part of ionization sphere. If it will be asked how many ion we can get from this, the number of ion we can get from this, first of all, as Cl is the negative one, so it will give you 2Cl minus, and inside one will give you 1 plus. So total 3 ions we can get from this compound. And the coordination sphere will never dissociate into ion. Only ionization sphere and the whole coordination sphere will give you one whole ion. Now next we are going for the oxidation state. If we go for chlorine outside of coordination sphere, here 2 chlorine means 2 negative, that can be neutralized by if the coordination sphere will be 2 positive. So if we withdraw the 2 chlorine atom, that means that coordination sphere only got 2 positive charge. Now if we assume the oxidation number of central metal atom, that means cobalt is X and the other ligand is Cl and amine NH3 group, and Cl will have the oxidation number -1. So we are having X -1 and 5 amine having 0. So plus 5 into 0 will be equals to 2 plus. So here X will be +3. So the oxidation number of cobalt will be +3 here. So these things, a calculation of coordination, calculation of oxidation number of central metal atom is very, very important. Next example we are having COCl3NH3 So as you can see here, coordination sphere is positively charged. Here coordination sphere is neutral in charge. So if we go for this, so cobalt having suppose X, 3 chlorine atom means 3 minus, and amine all 0 is equal to 0. So X will be in the +3 oxidation state. So cobalt is in here also +3 oxidation state. In the next compound, as you can see, K3FeCN6 is written. First of all, we have to know what is the oxidation number of the coordination sphere. If we withdraw the potassium ion, as the potassium is the electropositive one, so 3 potassium will give you 3 positive, and that 3 positive can be neutralized by 3 negative of the coordination sphere. So this will be your homework. So I hope you have understood, and you can comment below what is the coordination number you can find of iron here in this coordination sphere. And here the coordination sphere is ionic in nature. You have to find the oxidation number of iron. So you will find the oxidation number and comment me below. Now we will discuss the nomenclature of the coordination compound. Before going to nomenclature, one thing I want to discuss. Suppose we are having cyanide ion, okay, Cn-. So here the donation can be through C carbon side or through nitrogen side also. The 2 donor is possible. If we are going for suppose ethylene diamine, that means one ethylene molecule, each of the carbon is attached with NH2. So here as you can see, 2 nitrogen are donor as well as 2 nitrogen can donate at a time also. But in case of cyanide, any one of the atom can donate at a time. So like this way, if any compound contain more than one atom which can donate at a time, so there the donation number of donation site changes. This one is called the hapticity. Hapticity means through how many number of site it can donate at one time. So here the hapticity will be 2 and it can be donated by eta. So this here in case of ethylene diamine, the hapticity is 2. If we go for another example like ethylene diamine tetraacetate. Ethylene diamine tetraacetate. In case of ethylene diamine tetraacetate, the structure is NCH2, CH2N, each of the nitrogen attached with COO minus, CH, COO minus. CH3COO minus. Now you can see nitrogen having lone pair, it can donate through that. This nitrogen also having lone pair, it can donate through that. And here each of the oxygen can donate through its O minus. So here the total number of donor site is 1, 2, 3, 4, 5, 6. 6. So here the hapticity will be 6. And total number of donor atom is nitrogen and oxygen both. Like this way we can see the hapticity also. If we go for more example, we can see more more this type of ligand, their name, and how will be we can describe the hapticity. So to see more example and more ligands its name, follow my telegram channel. I will share all the documents with you them in my telegram channel. Okay, let's go for few of the IUPAC nomenclature. Okay, the very first thing about naming is whenever we are having cation, that will come first. Whenever we are having anion, that will come later. The main thing of telling that is, suppose a cationic complex, the cationic coordination complex we have, suppose the coordination complex looks like Ml whole x to y positive. Along with we are having one anion with Z y negative. So as this ionization sphere is anionic, so its name will come later. If it will look like Ml whole x y negative, along with ionization sphere is Zy positive. So here the name of complex will come later and the name of this ionization sphere cation will come first. Writing the name of the complex, we have to follow the cationic complex, anionic complex separately. For cationic and anionic complex, let's see what are the thing we have to follow. The first thing, no, if the complex is non-ionic, that means suppose platinum. Okay. Another thing is, if that one is non-ionic complex, then cation first, then anion. Name of the cation will come first, then anion. Ionic complex, one word explanation. Platinum, 2 chlorine, 2 amine group. Then amine group will come first, and because of 2, we will write diamine. Because of 2 chlorine, we will write 2 chloro and platinum 2. Now, how to write the ligand, that we will go for next. Let's see, for this ionic complex, potassium we have written the cation first, then AgCN whole 2, dicyanoargentate 1. 1 means the oxidation number. Let's see what is the next rule. The next rule, if we are having anionic ligand, as you can see we are having the anionic ligand chlorine, we will attach one extra letter O. If we will have cationic or neutral ligand, we will not attach anything for neutral ligand, but for cationic ligand, we will attach IUM. As you can see here, diamine is written, but if we are having cation, potassium written, already IUM there, the platinum, as here amine is neutral, so we have not attached anything, diamine. As we will go for next the ligand, if we see any cationic ligand, like for F minus fluoro, Cl minus fluoro, that one are anionic ligand, we have attached O. For NO positive nitrosonium, IUM. For phosphine neutral one, so this one nothing we will add. This one is the cationic ligand, so we are adding IUM. This one is the neutral ligand, we will not attach anything with the ligand. Next what we have, next we have more than one ligand, so we have to attach di, tri, tetra, penta, etc. We have to mention the oxidation number of central metal atom in the form of Roman 1, 2, 3, 4, etc. Ending of central metal atom. Then central metal atom ending will be for cationic and neutral complex. If the coordination complex will be cationic or neutral, the ending will be as it is, as the name. Anionic complex, the ending will be the name plus ATE. When we will see few examples, we can understand this. Next, see few examples. Okay. First of all, always there will be a gap between ionization sphere and coordination sphere. So as there are only coordination sphere present and the coordination complex is neutral in nature with the zero oxidation state, so here only one name we will write without any giving any space. First of all, now we will identify the central metal atom. Here the central metal atom is cobalt. Now we will find, as we are having multiple ligand here, so we will follow the alphabetical rule. means the first alphabet will come first. Now we are having bromine, nitro and amine. Amine starts with M, amine starts with A, and four amine group are there, so it will be tetraamine. So the name starts with tetraamine. Then we are having bromo, tetraamine bromo without giving any space. Then we are having nitro, tetraamine bromo, nitro. Then we are having cobalt, as this one is neutral complex, so cobalt we will write in the form of cobalt only, and we will write the oxidation number of the cobalt in Roman letter 2. So this will be the name tetraamine bromo nitro cobalt 2. Now going for the next K4FeCN6. As you can see, this one is the coordination sphere, this one is the ionization sphere. And ionization sphere is positive here. We will write the positive first, that one is potassium. Then we will give one space. After that we will write the coordination sphere. In coordination sphere we are having cyanide as ligand, iron as metal, central metal atom. First we have to find out the oxidation state of the iron. So if we consider oxidation state of the iron as X and cyanide having -1, so 6 minus, and we are having 4 minus in case of coordination sphere, as 4 potassium plus can be neutralized by 4 minus. So like this we can have the iron having in oxidation number of +2. +2 minus 6, it will give you 4 minus. That 4 minus will be neutralized by 4 plus of potassium ion. Now in case of coordination complex, writing the name of coordination complex, what we will do, we will write the name of the ligand first. That one is hexacyano, as this one is minus anionic ligand, we have added O. Hexacyano, and iron is ferrate. Ferrate we will write. Why ferrate we are writing? Ferrate At we are adding because the coordination complex is negative in charge. Ferrate, the oxidation number we will write in Roman 2. Its name will be potassium hexacyanoferrate 2. Next we will do this complex, this coordination complex naming. Naming of this complex, first see here. Now see, to find out the oxidation number, this coordination sphere will neutralize this coordination sphere. So if we take the oxidation state of cadmium as X, oxidation state of cobalt as Y, so what we can write, the oxidation number of this coordination sphere will be Y plus 0, and that will be neutralized with this one. So if it will be neutralized, suppose this one is Y positive, to neutralize this, so this negative of Y will be equals to X minus 5. Now we are having X plus Y equals to 5. Now we will choose the common oxidation state of cobalt and cadmium. As we know, the common oxidation state of cobalt and cadmium can be 3 and 2. So if we take cobalt as +3 and cadmium as +2, they will both give you +5. So we are having the name like, first we will write the positive coordination state. As you can see, if cadmium is in +2, Cl is 5. So here the coordination sphere will have the oxidation state of -3. Here this coordination sphere will have the oxidation state of +3. We will write the positive one first. So we will write here hexaamine cobalt, hexaamine cobalt with its oxidation number 3 first. Then giving a gap, we will write hexachlorocadmate, because negative coordination sphere ATE and the oxidation number is 2 here. This is the naming. And I am giving you one thing to do as homework. You will do and you will tell me the answer in comment box. I hope you will do, you will practice, so it will be good for you. Find out the IUPAC name for Na2 SiF6, and to give the name you have to know the name of the ligand, and you will give that in my Telegram channel, and the link will be given in the description box. And this one is a part 2 video. For more, I will discuss this type of thing in my next video of coordination number. So I hope this video is helpful for you. You have understood, the thing is clear to you. And if this video is helpful, please like it, and if you have not subscribed to my channel, please subscribe it, share with your friends, and thank you for watching.